Web 3 is the future, but it's still much harder to use than Web 2. The industry is fragmented across many blockchains, forcing Web 3 builders to choose between difficult compromises in centralization versus usability. These compromises were only necessary because Web 3 was incomplete. In May 2021, this all changed with the launch of the Internet Computer Protocol, or ICP. ICP is a decentralized cloud that bridges the gap between Web 2 and Web 3. To create ICP, over 100 cryptographers worked for 8 years to perfect an utterly new cryptography innovation. It's called chain key technology. But before we explain how it works, let's quickly look at the incredible things ICP can do. First, let's explore how decentralized applications on ICP compare with Web 2 applications. ICP has a powerful new type of smart contract called canisters. They are decentralized web servers that can directly host full websites with low latency. Canisters can store up to 400 gigabytes of data, perform complex calculations, and connect to Web 2 services and APIs without oracles. Users don't pay gas on ICP. When canisters do computations, they burn a token called cycles from a built-in wallet. This process is called a reverse gas model. Gas costs on ICP usually get paid by the core teams or DAOs that own the canisters, but some dApps collect assets to cover their gas costs themselves. The cycles needed to run canisters can only be minted by burning ICP tokens, and the mint ratio gets stabilized against the real-world costs of running the physical nodes that are doing the computation. The cost of hosting dApps on ICP is consistent and inexpensive, regardless of whether the price of ICP tokens goes up or down. The result is that canisters can deliver decentralized web experiences that look and feel indistinguishable from Web 2. Next, let's look into how ICP connects with the Web 3 world. Most Web 3 blockchains require bridges to connect to other chains. Bridges are built by deploying smart contracts on each chain and relaying transactions between them. Relaying transactions across chains often involves expensive cryptography computation, multi-sig wallets between trusted parties, and off-chain oracles. The complicated architecture of Web 3 bridges makes them slow, costly, difficult to use, and prone to security breaches. ICP canisters can directly sign transactions on other blockchains, such as Bitcoin and Ethereum, without bridges or centralized service providers. Canisters can mint ordinals on Bitcoin, deploy smart contracts on Ethereum, and do anything a human user can do across different Web 3 blockchains, effectively making them decentralized autonomous Web 3 users. The result is that ICP can abstract away the complexity of multi-chain transactions so that users can enjoy a seamless Web 3 experience. Chain key technology, the alien tech powering ICP, makes these incredible capabilities possible. To understand chain key, let's review how typical Web 3 secret keys work. When a Web 3 user wants to create a new blockchain transaction, they sign a message to the blockchain using a secret key that only they know. A threshold signature is when one secret key gets broken up into pieces held by different nodes in a network. Together, these nodes can collectively sign messages without ever revealing the entire secret key to any node in the network. Governments and militaries have been using threshold cryptography to protect their most valuable secrets since the 90s. However, these organizations only execute threshold signatures within controlled private networks. Blockchain networks must be public, trustless, and decentralized. Web 3 nodes might be offline or malicious, and an attacker might even try to collect the pieces of the secret key over time. Secure threshold signatures on Web 3 were impossible until the Dfinity Foundation invented chain key technology. With chain key, up to 1/3 of nodes could be offline or malicious, and the network can still generate a secure signature. The pieces of the secret key stored on each node are also constantly scrambling, so that any information leaked from a node is useless to attackers. This makes it possible to create a decentralized network that can use secret keys no human or computer will ever know. Dfinity built ICP on top of chain key technology to completely reimagine what an L1 blockchain could be, with the vision of creating a fully decentralized internet. For example, anyone can verify the content received from the internet computer by simply validating a signature without syncing the entire blockchain. In addition, 0% of ICP nodes run on AWS or other big tech cloud providers. ICP nodes are themselves independent private clouds running in data centers all over the world. Furthermore, nodes on ICP only act as vendors for an on-chain DAO that manages an ICP network, called the Network Nervous System, or NNS. ICP holders who stake tokens in the NNS are the only ones who can control the source code of the network, and they can collectively update the network without hard forks. ICP is entirely alien to anything else within Web 2 or Web 3, which makes it perfect for connecting the two in ways never possible before. With Bitcoin, humanity got the first decentralized network. With Ethereum, humanity got the first decentralized logic. With ICP, humanity now has the first decentralized secret keys, the first decentralized cloud, and the first decentralized AI models. Oh yeah, did we mention that ICP is the only blockchain that can fully host AI models on-chain? Now that is alien tech. The future of the internet belongs to everyone, and it won't be harder to use. Whatever blockchains you love and whatever Web3 future you're fighting for, ICP's alien tech will be a part of it. Explore what ICP has to offer and take your place in the Web3 invasion.